Okay, so this one is the lesson 2 notes where we're doing reciprocal family functions. So this is the parent graph that we start with. Okay, so when I'm looking at this for domain and range and looking at my asymptotes also, what I want to look at is numbers that I can't put in for x. So when I look at this equation, if I put 0 in for the x value, what's going to happen is it's going to be undefined. So what I know is that my domain is going to be all real numbers, which is this double R, except 0, because I can't have anything at 0. So if I can't have anything at 0, that's going to give me this. That's what we call an asymptote. Okay, so my vertical asymptote is going to be at x equals 0. So then, let's say that I solve this equation and solve it for x. I would multiply the x to the other side, and then I would divide it by y. So 1 over y. Okay, so this is how I find the range. I solve it for x, and then I look at it and I say, okay, what can't I put in for y? Well, I can't put 0 in. So the range is going to be all real numbers except 0. So again, I can't put anything for 0 here. So that means my horizontal asymptote is y equals 0. Okay, so those are two lines where nothing can happen at. So what I want to do now is plug in values into a table. Okay, so I have my x's already given to me. So I'm going to plug that in. So 1 over negative 2, well, that's just negative 0.5. So I go over here and graph this. Back 2 and down a half. Okay, now I'm going to put in negative 1. So positive 1 over negative 1 is negative 1. So back 1, down 1. Put in a half. So 1 divided by negative 1/2. Okay, so what that does now is I have to multiply this by the reciprocal, so it gives me 1 times negative 2 over 1, which is negative 2. So over a half and down 2. Now when I go to 0, that's going to be undefined. I can't put 0 in there because I can't divide by 0. All right, so now I'm going to go ahead and make this side of my graph, because now from this point forward, we're jumping to positive numbers. So if I put in 1/2, I have 1 over 1/2, which is really 1 times 2 over 1, which is 2. So I go over a half and up 2. Okay, if I put in 1, 1 divided by 1 is 1. It's the ordered pair, 1, 1. If I put in 2, 1 over 2 is a half. So if I go over 2 and up a half. Okay, there's the other side of my graph. So this is the parent function. So from this, we're going to adjust all of our other graphs based on this one alone. So now let's look at one where we're stretching it a little bit. So the 4 that's up top tells me that I'm going to stretch. Okay, so it's not going to look quite like our last one because we're stretching this. So again, I want to go ahead and look and say, okay, what can't I put in for x? Well, the only thing that would make it undefined would be 0. So my domain cannot equal 0. So for x's, I can't put in 0. So what that means is my vertical asymptote is x equals 0. For my range, if I switch this around and solve it for x, I would get x equals 4 over y. Okay, so in terms of what I could put in for y, I still can't put a 0 in the bottom because that would make it undefined. So that's going to put this line going across here. So then that makes my horizontal asymptote be y equals 0. Okay, so this time I didn't give you all the numbers in the graph, so you have to pick. So the way that you decide what you want to put in for x and y is I say, okay, what's going to divide 4 really nicely? So things that'll go in nicely would be 1/2. 4 divided by 1/2 is really 4 times 2 over 1, which is 8. So if I go over positive a half and I go up 8, goes off my graph a little bit, but you can guesstimate. So now I'm going in order. So after a half, the next biggest number would be 1. Well, 4 divided by 1 is 4. So over 1 and up 4 is my next point. Next nice number would be 2. 4 divided by 2 is 2. So 2, 2. 3 obviously won't work. 4. 4 divided by 4 is 1. So over 4, up 1. And then the last thing I would put in there that's a nice number is 8, because 4 over 8 reduces down to 1/2. So I go over 8 and up a half. So here's the first part of my graph. Okay, so what I know is that my values are positive, so this is going to be quadrant 1 and quadrant 3. So quadrant 3 is this one. Well, what I know about that is my x's are negative and my y's are negative. So all I'm doing is making it negative 1/2, negative 8, negative 1, negative 4, negative 2, negative 2. Just making all of these be negative. And then plotting those. So back 1/2 and down 8, back 1 and down 4, back 2 and down 2, back 4 and down 1, and 8 and negative 1/2. So that's my other one. Obviously, you don't need to keep that boxed in. I was just telling you that that's where that quadrant was. Okay, so this stretched away from the axis. It's not quite as close as the other one was. So our last example is that now we're changing everything in this. So remember our original equation was a over x minus h plus k. So here's what happens. This value is my vertical asymptote, and it's going to be the opposite. This value is going to be my horizontal asymptote, and it's going to be the same. That's kind of sloppy, sorry. And then the a value just tells us if we're stretching or not. Okay, so here's what we're going to do first is find our asymptotes and then decide on our domain and range. Okay, so looking at the bottom of this, we get negative 2. Okay, so this is my vertical. So I'm going to take x minus 2 and set it equal to 0 to get the opposite. Well, the opposite of that is 2. So my vertical asymptote on this is at x equals 2. Then my horizontal asymptote is just the same as my one before. It's the same as it is up top. So it's y equals 3. Okay, so really all I did was I took my center at 0, 0, and I dragged it up to this. So it's kind of just shifted where things are at just a little bit. Now because of this, I can tell you my domain and my range. My domain is my x's, so I can go all the way across until I get to 2. So what I can say is I can go from negative infinity to 2. Then I can also go from 2 to positive infinity. I just can't be at 2. So that's what that's saying. This is just a different way of writing your domain and range besides all the reals except something. You just might see it both ways, so I want to go ahead and show you both ways. This one is my y values, so I can climb the y-axis until I get to 3, and then I have to stop. Okay, so let's go with the hard part first, which is the x-intercept. The x-intercept, what that really means is I'm putting y in as 0. So I'm putting this into the equation, 1 over x minus 2 plus 3. And then I'm going to go ahead and solve it for x. Subtract the 3. Now, what I can do is I can flip-flop these two, which there's a reason behind it, but just for the sake of this video, I'm just going to tell you can flip-flop it. And get this. Now I'm just going to add 2 to the other side. So I get negative 1/3, and I'm adding 2 to it. So what that is going to give me is negative 1.66, 1.67-ish. Okay, so that's my x-axis. That's my x equals. So x equals 1.66 is here. Okay, so I have to reflect this. So what I want is for it to be in quadrant 1. So here's what I did. I went 1, 2, 3 down and over a little bit. So I'm going to go 1, 2, 3 up and over just a little. That's my reflected point. Now for my y-intercept, that means that x equals 0. So I'm going to plug that into my equation. 0 minus 2 plus 3. So I get negative 1/2 plus 3, which is 2.5 as my y value. Okay, so if y is 2.5, that's right here. So what I'm doing here is I'm going 1, 2 over and down 1/2. So I'm going to go 1, 2 over and up 1/2. Now I have 2 points that I can make my graph of this. So just remember that as you're counting your distance from our new origin. Hope you're getting to see all of this.